This is Lab 2, a continuation of the charged tapes lab from Lab 1. Okay, to start off, our purpose for this lab is to accurately determine the amount of excess charge on the tape. In Lab 1, we found the charge to be 8.18 times 10 to the negative 9th, and in this lab, we found it to be 1.85 times 10 to the negative 8th. So the main physics ideas we're working with, again, Newton's second law. F equals ma, gravitational acceleration is baby g, 9.81 meters per second squared. Our electric force is Coulomb's law, so F equals kqq over r squared, where k is 1 over 4 pi epsilon naught. And we also have the electric force is equal to the charge of a charge times the electric field. And we still have the mass of the clear tape and the charge of an electron. So we are no longer assuming that the charges are equally distributed throughout the tape pieces, because they're not. We cannot treat this system as a point charge and get an accurate charge. We are still assuming that they have the same charge, but that could also be wrong. And we are assuming that air resistance and other outside forces are negligible for our experiment. So our system and surroundings, again, tape A, tape B in the system, meter 6 in the system, everything else out of the system. The experiment is performed the same way it was in Lab 1, so we don't need to go over that. Okay, so our glow script. Here you can see we are initializing some physical constants. So our tape length is 0.17, which we measured with a meter stick, and then the floating distance is like how far the tapes were apart from each other when one of them started floating. We find the mass. And then down here, we find what the accurate Q is going to be. So we found that it must be multiplied by a factor of 2.25625 in order for the model to work. We found that it was this number by substituting in different numbers and seeing which one would give us an accurate Q, and an accurate Q would be when the force electric equals the force of gravity. Okay, here we're just initializing the tapes as objects in our code. Here we are calculating the forces on each piece of tape by using the electric field and then multiplying that and using superposition to add it all up. And then we just model it. So here we can see the model for the charge that we found in the first lab, and the magnitude of the electric force is not equal to the magnitude of the gravitational force. So the method that we used to find the charge in the last lab is not an accurate method. And then here we see the magnitude of the electric force is equal to the magnitude of the gravitational force with the charge that we found in this lab. So that's good. Okay. So the reason we had to multiply it by that number was because we are no longer treating it as a point charge. So the mass or the charge of the tape is not going to be like a point charge. Some sources of error, the assumption that the tapes had equal charge could still be incorrect, and the charge of the tapes could have been impacted by our handling of the tapes. Okay, so what if we had modeled each of the tapes as a single point charge like in the previous lab? Well, if we had done this, then the actual point charge that we would find in this kind of model would be much smaller than what it actually needs to be, because we had to multiply the charge that we found in the last lab by a big number. We know that the number was originally too small. And we see that in the models that we have from the glow script code. And then, what does it mean? Why do these estimates differ? Which value is more likely to be closer to the real value? Well, the model where we use the tape as not as a point charge is going to be more accurate, because using it as a point charge decreases your level of precision. The line charge model uses smaller step sizes, which is more accurate to real life, which is why it is the more accurate model, whereas the point charge model uses bigger step sizes, so it is not as accurate.